Okay, so this is the College Algebra Fall 2024 Exam 1 review. So we're going to be starting with question 1. We just need to solve this equation. So the first thing that we should do here is try and distribute everything out and then combine all our like terms and get all our t's to one side, basically. So we have negative 8 times t minus 4 plus 7 equals 4 times t minus 3, 1 minus t, plus 6. So first we can distribute this negative 8 out. So we're going to get negative 8t plus 32 plus 7. And then we can start distributing, and ideally we kind of want to distribute from the inside out. So first let's start with this negative 3 here. We'll distribute to this, to that. So we wind up with t minus 3 plus 3t plus 6. So we can go ahead and combine a couple like terms on this side. So we have negative 8t plus 39 equals 4. And then we combine our t's inside of here, and we get 4t minus 3 plus 6. So now we can distribute this 4 to both our terms. So we have negative 8t plus 39 equals 16t minus 12 plus 6. Then combine like terms, 16t minus 6. So now we want to get all our t's to the same side. So if we add 8t to both sides, and then we can also add 6 to both sides. So we wind up with 45 equals 24t. Then we can divide both sides by 24. We wind up with t equals 45 over 24. So from here, we can work on simplifying this fraction down. So both of these have a 3 in common. So this is 3 times 15 over 3 times 8. So then we can cancel out those 3's, and we just get t equals 15 over 8. Okay, so for number 2, first looking at A, we're going to identify the following equations as conditional, identity, or contradiction. So our first thing that we're going to want to do is just work on simplifying this equation. So starting with 2x plus 16 equals 10x minus 8 times x minus 2. So let's distribute this out to both of these terms. We get 2x plus 16 equals 10x minus 8x plus 16. Now we can combine some like terms. So we have 2x plus 16 equals 2x plus 16. Well, okay, since we winded up with the same thing on both sides, it means that no matter what we plug in for x, our equation is going to work. So what we call that is just an identity. Okay, let's go through the same thing for part B. We're just going to work on simplifying it to start. So plus 4 equals negative 2. 3 plus 4 is 2x plus 5. Okay, so distribute everything. Minus 15 plus 4 equals negative 2. 3 plus 8x plus 20. And then we can combine 3 and 20 inside of these parentheses here, or brackets, sorry. So we're going to have 3x, and then we can combine negative 15 and 4. So it's going to be 3x minus 11 equals negative 2 times 8x plus 23. So we wind up with 3x minus 11 equals negative 16x minus 46. So now we can get all our x's on the same side and move everything else to the opposite side. So we wind up with 19x equals, we'll have negative 46 plus 11. So that is going to be negative 35. So x equals negative 35 over 19. So because we got a number here, we got a solution for x. That means that our equation for part B is simply conditional, because it means that it works so long as x is equal to this. So, okay, for part C, we're going to do the same thing we did before, where we're just going to work on simplifying and distributing everything out. Oops, that's supposed to be minus. X minus 4 equals 3x plus 1 minus 5. Okay, so if we distribute everything out, we're going to have plus 2x minus 8 equals 3x plus 3 minus 5. So now we combine all our like terms. We wind up with 3x minus 13 equals 3x minus 2. So if we notice here, no matter what we plug in for x, we're not going to get something that works. And we can see that even further if we subtract 3x from both sides, we end up with negative 13 equals negative 2, which we know does not. So because of that, we're going to call equation C a contradiction. Okay, so starting with 3a here, we're going to solve the following rational equations. So anytime we're given an equation and there's a bunch of fractions, one good thing is to get a common denominator. So if we can think of something that 2, 4, and 3 all go into evenly, that can work really well. Another thing that you can always do is just take 2 times 4 times 3 is 6 times 4, or 24. So we could use that. Alternatively, a number like 12 could work. So if we make them all under 12, then we'll have one common denominator. So w over 2 minus 3/4 equals 2w over 3 plus 2 over 1. So if we make them all 12, this is going to be, it's missing for this number here, it's missing basically a factor of 6. So we multiply that one by 6 over 6. So we get 6w over 12. And then the next one is missing a factor of 3, because 12 divided by 4 is 3. So we're going to get 3 times 3 is 9, over 4 times 3 is 12. And then next, 12 divided by 3 is 4, so we're missing a factor of 4. So 4 times 2w over 12. And then 2 times 12 is 24, 12. So now we have all common denominators, so we can go ahead and multiply the whole thing by 12. So if we do that, we get rid of all of our fractions. So from here, we can go ahead and get all our w's on the same side. So if we subtract 6w, we'll have 2w, and then we can subtract 24. And if we do that, we get negative 33. So now we just divide by 2, and we get that w equals negative 33 over 2. Okay, part B, we have x plus 2 over 3 minus x minus 4 over 4. 2 over 3 minus x minus 4 plus 1 equals x plus 1 over 6. So we want to get a common denominator for all of these. So you can either, if there's one that you can think of, or a lot of the times what will always work is if you just take all the numbers and you multiply them together. So in this case, you would get 12 times 6, 72, which is kind of a big number, so we can maybe look for a smaller one. So one that I can see is 12. So 12 is probably one that's going to come up a lot just because so many numbers go into it nicely. So we want to figure out what factor is missing to make all of our denominators 12. So for x plus 2 over 3, we're missing a 4 because 12 divided by 3 is 4. So we're going to have 4 times x plus 2 over 3. And this 4 gets distributed to both these numbers. So I'm just going to go ahead and take a step ahead and write it as 4x plus 8. This next one is missing a factor of 3, so we're going to have 3x minus 3 times 4 is 12 over 12, and I just realized I forgot to do this, sorry. 12, okay, and then this one, we're multiplying by 12 over 12, so we're going to have 12 over 12, and then for our last one, 12 divided by 6 is 2, so we multiply the top by 2 over 2, so we get 2x plus 2 over 12. So now we have 12 in all of our denominators, so if we multiply everything by 12, we get rid of all our fractions, and we're left with 4x plus 8 minus 3x, be careful with distributing negatives, equals 2x plus 2. So if we combine some like terms here, this is going to be x here, then we're going to have plus 8 plus 12 plus 12, so that is going to be plus 32 equals 2x plus 2. So now we can move this x to the opposite side and subtract 2 from both sides. So we're going to have 30 equals x. Okay, so x equals 30. Okay, moving on to part C here. We see that we have these fractions here, and we also have things that we can work on factoring, like this here. And we're going to use all this to kind of get everything as a common denominator and then multiply it out. So why don't we start by just factoring y squared plus 3y minus 4. So we want two numbers that multiply to negative 4 and add to 3. So we know one of them has to be positive, one of them has to be negative. So one of them that might work is a positive 4 and a negative 1. So 4 times negative 1 is negative 4. 4 plus negative 1 is 3. So that means that this is the same thing as y minus 1 times y plus 4. Okay, so we're going to use this to substitute it right there. Okay, so writing everything out, we have 1 over y minus 1 equals 5y over y minus 1 times y plus 4 minus 3 over y plus 4. So if we want everything to be a common denominator, notice how all that this is missing from this is a y minus 1, and all that this is missing from this is a y plus 4. So we can take this part here and multiply it by a y minus 1 over a y minus 1. So whenever we do that, we're multiplying, it's basically just multiplying by 1 because they cancel each other out. So we're not like altering our equation really, it's just allowing us to rewrite it. Then we can do the same thing on this side if we multiply by y plus 4 over y plus 4. I'm running out of space. Okay, so now we just need to kind of distribute these numbers out, and then we'll have everything be one denominator. So on the left side, we're going to have y plus 4 over y plus 4 times y minus 1 equals 5y over y minus 1 times y plus 4. So, and because this has the same denominator as this, I'm going to move this to right here. So we're going to have 5y minus 3y and then plus 3. Remember, we need to distribute this negative to here. And then from here, we can go ahead and combine some like terms. So this 5y minus 3y, that is just going to be 2y. So 2y. So now we can go ahead and multiply both sides by y minus 1 over y plus, or y minus 1 times y plus 4. Plus 4. We do the same thing on this side, y minus 1, y plus 4. Nope. sorry. So from here, this is going to cancel with this. This is going to cancel with this. This will cancel with this, and that and that. So after all that cancels, all that we're left with is this. So from here, we can go ahead and work on solving this, and we get that y is going to equal 1. So this is our answer here. But before we finish, the one thing that we need to look at is what can our original equation not contain? This right here. So if we notice, if we were to plug 1 in right here, we're going to have 1 over 1 minus 1. Well, that's just going to be 1 over 0. So because we get a 1 over 0, or any number over 0, that number is not included in our solutions. So we find that even though all of this simplified to y equals 1, we can't actually plug y equals 1 in, which means that we have no solution.
Okay, we're going to solve question 4 now, part A. Oh, let me get my pen tool here. A, and we're going to solve for variable p. So I equals PRT. We divide both sides by R and T. And we get that P is equal to IRT. Okay. Let's do part B now. We are solving for variable t2. So we'll write this t0 is equal to t1 plus t2 all over 2. So where this is in a fraction, the 2 in the denominator, we're going to multiply both sides by 2. So we get 2t0 is equal to t1 plus t2. And now we are going to subtract off t1 from both sides. Now we get 2t0 minus t1 is equal to t2. And now we're going to rearrange it so that way we have the thing that we're solving for on the left-hand side equal to the remaining parts. Okay, we'll be going on to 5, which reads, Dexter's hybrid car gets 41 miles per gallon in the city and 36 miles per gallon on the highway. The amount of gas he uses, A, in gallon is used by A equals 1 over 41 times C plus 1 over 36H, where C is the number of city miles driven and H is the number of highway miles driven. If Dexter drove 288 miles on the highway and used a total of 11 gal of gas, how many city miles would he drive? Okay, so we're going to write that equation over here. Awesome, and now we're going to replace things that we know. So the first number that we're given is 288 miles on the highway. And the only other bit of information is that we know that they used 11 miles of gas. So now with that, we can simplify which 288 divided by 36 should be 8. Now we are going to subtract 8 from both sides, giving us 3 is equal to 41C. To get that 41 out of the denominator, we're going to multiply both sides by 41, which should give us 123C is equal to C. Now C is the number of city miles that we have driven. And because this was asked in a paragraph, we're going to respond with a sentence.
Okay, so looking at number 6 here, a contractor must tile a rectangle kitchen that is 4 foot longer than it is wide, and the perimeter of the kitchen is 48 feet. So, perimeter is equal to 48 feet. We have our width, and we know that our length is equal to 4 plus our width. It's 4 times longer. 4 foot longer, not 4 times longer. So, perimeter is equal to 2W plus 2L. We know that L is equal to 4 plus W. So we want to solve this for W here. So 48 is going to be equal to 2W plus 2 times 4 is 8 plus 2W. I'm going to combine like terms. So minus 8 here, minus 8. So 40 is going to equal 4W. So that means that W is going to equal 10 feet. So now we're going to find our length using this. Length is equal to 4 plus W. It's equal to 4 plus 10. So our length is equal to 14 feet. So this means that our dimension of our kitchen is 14 feet. 14 feet by 10 feet. All right, so looking at number 7 here, we have a simple interest question. So I'm going to start off by writing a table. So we have our treasury and our bond. So we're going to have our principal here, our rate here, and our time here. So our principal for our treasury we want to find out. We're going to call it X. Our rate for our treasury is 3.5%, and our time is 10 years. Same for our bond, it's 4,000 more than our treasury, so X plus 4,000. Our rate is 4.1%, and our time is 15 years. So next we want to think about what the simple interest equation is. It's I is equal to PRT. So we know what our I is. It is 10,180. It's equal to our principal of each added together. So principal of X times our rate, which we're going to convert to a decimal, 3.5, times our time of 10 years, and then plus X plus 4,000 times 0.041 times 15. Next thing I want to do is just kind of simplify all this, bring this 10,180 down, and then we're going to have 0.035 times 10, so 0.35x plus X plus 4,000 times 0.041 times 15, 0.615. Next thing we're going to want to do is distribute that 0.615 to the X and the 4,000. So we're going to have 10,180 is equal to 0.35x plus 0.615x, and then plus 2,460. So now I want to get all of our like terms together. So I'm going to subtract that 2,460 on both sides. Then I'm going to combine our 0.35 and our 0.615. So 10,180 minus 2,460. We're going to have 7,720 is equal to 0.35 plus 0.615, 0.965x. We want to solve for x, so I'm going to divide 0.965, 0.965. So x is equal to 7,720 divided by 0.965. It's going to leave us with $8,000 in our treasury investment. Define what we've invested in the bond. We're going to do the bond is equal to the treasury amount plus 4,000. So 8,000 plus 4,000. So our bond is going to have $12,000 principal.
Okay, so for number 8, we're having someone commute to work at an average speed of 45 miles per hour, and then on the way home, he averages 30 miles per hour, and the total time for the round trip was 50 minutes or 5/6 hours, and we need to determine the distance between his place of work and his home. So we need to remember that distance equals speed times time, okay? So from here, we also know that time equals distance divided by speed. So in this case, we have hours is going to equal miles over miles per hour. So if we think about our total time is 5/6 hours, and this is going to be equal to the speed that we go there, or excuse me, the distance there over the speed. So the distance, let's just say that that's X amount, X miles away. Oops. X miles over our speed, which was 45 miles per hour. And then we're also going to have the trip back. So the trip back, we went the same distance, so we'll just call it X again, over our speed on the way back, which was 30 miles per hour. So from here, we have one equation, which is the one unknown variable. So we need to solve for X, and that should tell us our answer. So we can start by getting a common denominator for the X over 45 and X over 30. Or one thing we can do is maybe multiply by sort of like a factor that they both have. So if we multiply the whole thing by 45 to solve for X, we're going to get 45 times 5/6 equals X plus, so 45 over 30 is just the same thing as 3/2 X. So we have 45 times 5 is 225, and then we can divide it by 6 to get 75/2 equals 5/2 X. So from here, we can multiply by 2 on both sides, and we get 75 equals 5X. And then we can divide by 5, and we get that X equals 15 miles. So the distance between his place of work and his home was 15 miles. Okay, so for number 9, we have one of these sort of rate questions, except for it's not with the most like conventional units. So it's the same basic idea that we're going to have some amount equals a rate times a time. And we're going to use this to help us solve, except for here we have a swimming pool being filled where one hose requires 3 hours and another one requires a different time. So our units aren't going to be as easy as miles, miles per hour, and hours. So we're still going to have T as time, or as hours, sorry. Except for now this A, which used to be like our distance, is just going to be in the amount, or we're just going to say like one pool or something. And R1 will represent the rate that it takes to fill in pools per hour, which is really weird, but it works the exact same as speed is in like miles per hour. So if your R1 was like 0.5, that means that you would fill half the pool in 1 hour. So if we use what we know, so using water from one hose requires 3 hours to fill. So the one pool is R1 times 3. So we find that the first hose fills at a rate of 1/3 of the pool per hour, basically. And you don't really need to get too caught up in the units because I know they're a little bit weird, but you really just want to focus on knowing how this works here. So the next one that we're given is that a second hose, let's see, if a second hose is turned on, the pool can be filled in 1.2 hours. So now we have 2 hoses. So we have our one pool equals our rate 1, which was 1/3, plus the rate that the second hose goes at, and that takes how long? It takes 1.2 hours. So now if we solve for R2 here, we can go ahead and distribute this out. So we get 1.2 divided by 3 is 0.4 plus 1.2 R2. So from here we get 0.6 equals 1.2 R2. So R2 equals 0.5, and this is our rate. So it's the number of pools that we fill per hour, basically. So we fill half the pool in 1 hour. So if we want to know how long it takes to fill one pool, we just have R2, which is 0.5, times the time that we want to solve for. And from this, we get that our time is equal to 2 hours. So how long would it take for the second hose to fill the pool alone? It's just T equals 2 hours. Okay, so for number 10, on a police force, there are 60 more male officers than police officers. So what I can do here is I can say that M equals the number of male officers and F equals the number of female officers. So we know that the number of male officers equals the number of female plus 60. And then it also tells us that the ratio of male to female officers is 10:7. So what that means is M over F is equal to 10/7 because it's a ratio. And then we need to determine the number of male officers and the number of female officers on the force. So basically we use those two equations here to solve for M and F. So if we were to take this equation here and plug it in, we would get F plus 60 over F equals 10/7. So now we can multiply both sides by F. We get F plus 60 equals 10/7 F. So now we can subtract F from both sides and we get that 60 equals, so 10/7 minus 1 is just going to be 3/7 F. And now we just solve for F here, so we're going to have 60 times 7, which is 420, and then we divide that by 3, so we get that F equals 140. So F equals 140 officers. And then we can take this and plug it back in right here. Or we could plug it into our ratio, either way. But this one here is already solved for M, so it's just a little easier. So you know M is just equal to 140 plus 60, so 200. So M equals 200 officers. Okay, so for 11, starting with A, write each of the following expressions in terms of I and simplify. Okay, so starting with square root, negative 144. So this is the same thing as the square root of negative 1 times 144, basically. And we know that the square root of negative 1 is just I, so we can go ahead and pull that out. Say this is I times the square root of 144. So now we just need to figure out what the square root of 144 is. So that one's pretty easy because it's just a nice, perfect 。So we know that this is just going to be 12 times I. And again, the reason is because the square root 144 is the same thing as 12 times 12. So from here, because we have two of them and it's a square root, we each get to take one out basically. So this one here is 12i. So now looking at b, we have negative square root of negative 75. So negative square root negative 75. Okay, so what we can do to start with is do what we did before and kind of factor out that I. So a square root of negative 1 is just I, so we get negative I square root 75. So now we need to figure out this here. So we want to think of, because 75 isn't a perfect square, we need to think of some perfect squares that can go into it. So one that I can think of is 25 times 3, and 25 is a perfect square. So we can rewrite this as negative I square root 25 times 3. So from here, this is just going to be negative 5i square root of 3. Okay, looking at C, I can see we kind of have a little bit of a trick here. So you might be tempted to say that the square root of negative 16 times the square root of negative 9 is the same thing as the square root negative 16 times negative 9. But this isn't the case, because we need to account for the fact that these are negative right here. These are already kind of imaginary. So starting with this one here, square root of negative 16, we know that that's going to be square root of negative 1 times 16, or just 4i. And then we're also going to have times 3i here. So we wind up with 12i squared. And 12i squared is the exact same thing as negative 12, because if I equals the square root of negative 1, and we square both sides, we find that I squared equals negative 1. So this one here is negative 12. Okay, and lastly, part D. So this is really similar to part C. So just like before, we have to take care of the negative square root part before we can combine them. Except for now, they aren't going to work out quite as well. So we know that both these are going to be able to pull an I out. So now we just need to figure out what square root of 32 and square root of 8 is. So the square root of 32, we can think of some numbers that go into 32. Well, we know 4 times 8 is 1, but also we have 16 times 2. So 16 times 2, we can pull a 4 out from that 16 because that's a perfect square. And we're just going to be left with 4 times the square root of 2. Now let's look at square root of 8. We can pull a 4 times 2. So a 4 is a perfect square, which means that we can pull a 2 out, and we'll be left with 2 square root of 2. So if we put these together now, we have 4i square root of 2 times 2i square root of 2. So now we just need to put everything together. So 4 times 2 is going to be 8. I times I is going to be negative 1. Square root 2 times square root 2 is going to be just 2. So really, we're going to have 8 times 2 times negative 1, or just negative 16. Oops. Okay, so for number 12, before I start these, I kind of want to briefly review. So we know that I is equal to the square root of negative 1. So I squared is going to be negative 1. I cubed is going to be negative 1 times I, or just equal to negative I. and I to the fourth is the same thing as I squared times I squared, or just 1. So the way I like to approach these questions, like in 12, is to look at the power here and divide it by 4. So if we divide it by 4 and we have a remainder of 1 after dividing by 4, so something like this, what we'll have left with is just I. If we get 2 over 4, we'll get negative 1. 3 over 4, we get negative I. And then 4 over 4 is 1. So, and this just follows, these just follow this here, basically. So, I to the first power, it's just going to be I. I to the second power is just going to be negative 1. I to the third, negative I to the fourth, it's just 1. So if we start with A here, we have I to the 53rd. So if we divide 53 by 4, we see it's not gonna, we're gonna get a remainder. So 53 divided by 4 is, is equal to 13.25. So because we got this remainder here, this kind of correlates with this. So we should expect that our answer is just going to be equal to I. And where that comes from, again, is just because we're going to have, we can rewrite this as I to the 52nd times I, and I to the 52nd, because that's evenly divisible by 4, we know it's just going to be 1, because we could just keep breaking it down into I to the fourths, basically. So now let's look at B. So B, we have I to the 84th. So if we divide this 84 by 4, let's see what we get. We get 21. So because we got no remainder here, that lines up with this case here, where we have no remainder, no fraction left over, which means that our answer is just going to be 1. And that's because if we were to just keep multiplying these i's through, eventually we'd get to 84 and we would just cycle back to 1. So it's just kind of like a repeating cycle.